Hello everyone, welcome to JG Chemistry. Today we are going to learn solubility product in precipitation titration. It is one of the most important topic or concept in precipitation titration to know. So let's begin. Solubility product we represent it by KSP. So we'll see what is that. It is the product of dissolved ion concentration raised to the power of their stoichiometric coefficient. We'll see it is kind of a equilibrium constant. So let's say this example silver chloride. When you make an aqueous solution of it, it dissociate into ions silver and chloride. So if you want to see the solubility of this precipitate which slide soluble when you make a aqueous solution, so the solubility product is the concentration of the dissolved species. Here the species is silver and chloride. So KSP you can calculate for silver chloride by the product of both concentration. Similarly, if you have silver chromate, we'll see the dissociation reaction of it. You will form 2Ag plus here and CrO4 minus. So if you want to calculate the solubility product of the following reaction, one can calculate the concentration of Ag plus raised to the power its stoichiometry, which is 2, and then the concentration of chromate. So if you put this formula, you can calculate the solubility product for the given reaction. Now, few points to keep in your mind that we always need the solubility of the precipitate as minimum as possible. So basically the solubility product should be small, right? So that we can say it has the lower solubility. So basically to lower the solubility, you should have KSP as minimum as possible. And basically it is temperature dependent. So whenever they are giving you the reaction, they should mention the temperature also, because as the temperature changes, the solubility product value changes. Now we'll apply this to solve the problem. Now they are asking the concentration of silver and chloride to calculate in saturated solution of AgCl and also the molar solubility of AgCl in water. Solubility product is given. So we know what is the reaction we have already seen, and let's say the concentration of Ag plus is X and so Cl minus, and we are familiar of the formula of solubility product. They are asking you to calculate the concentration of the species, that is Ag plus and Cl minus. Solubility product is given. You can calculate by keeping the, instead of Ag plus and Cl minus, you can write down X and bring out this formula. Put the value of solubility product which is given. You will find the concentration of Ag plus, which is equal to the concentration of Cl minus, that is 1.34 into 10 to the power minus 5 moles. And they are asking you the molar solubility. So basically the solubility will be dependent on the dissociation, right? How much amount of dissociated. So you can say the mole of AgCl is dissolved is equal to the solubility of AgCl. So basically the concentration which you have just now calculated is equal to the solubility of AgCl. X is equal to the solubility. So the answer is the same. Solubility will be 1.34 into 10 to the power minus 5. So very easily you can calculate the solubility product. In this, you have one more important concept called common ion effect. What is that? So as I told you that the solubility has to be less or minimum. So to decrease the solubility, we should add a common ion there. So if you have large concentration of the common ion, that decrease the solubility of the precipitate. Let's see example for this. So they are asking you to calculate the solubility of AgCl in 0.1 molar KCl solution. Solubility product is given. KCl, you can see here common ion is chloride, right? So same equation, AgCl, it is going to ionize. We have now concentration of silver is X. Since your common ion is chloride, so the chloride ion concentration you can write down 0.1 plus X, right? X you have already for silver plus and Cl minus, and moreover you have a concentration of KCl, right, solution, which you can write down here 0.1 plus X. Now place this value in the given formula and find out the X value. We can assume that this X is going to be very small. You can neglect it, so you can put instead of 0.1 plus x, you can write down x here, 0.1 x, and then you find out the value of x, and you got 1.8 into 10 to the power minus 9 mole per liter. So if you just compare this value from the previous problem, the first problem, where we have calculated 1.34 into 10 to the power minus 5 in the absence of common ion. Now in the presence of common ion, it is decreased to 10 to the power minus 9. That proves that if you have common ions, that decreases the solubility drastically. Similar kind of problem, they are asking you to solve and calculate the solubility of silver sulfate. KSP is given. So I hope you can write down the equation. Since you have 2 Ag plus, we can write 2x here. And the KSP formula, we know the concentration raised to the power is stoichiometry. In this, you can put the value for silver plus, it is 2x whole square in x for sulfate. You get the formula for the x calculation, KSP is given, and finally you can calculate it, comes to 1 into 10 to the power minus 4 mole per liter. Since the concentration of this species is going to be equal to the solubility, so basically the solubility of silver sulfate is going to be equal 1 into 10 to the power minus 4. We have seen this in the first problem. In this problem, they are asking you same molar solubility and as well as the solubility in gram per liter for silver chromate. Molecular weight is given, KSP is given. So we know how to calculate molar solubility. We have solved just now. Same method you can use here and find out the solubility, that is 6.6 into 10 to the power minus 5 mole per liter, which is a solubility, as well as the concentration. Ag plus concentration, if you want to calculate that, you just have to multiply it with 2 if they are asking you to call concentration of Ag plus, and this solubility is the same value for chromate. Now how to calculate in gram per liter? So you can multiply this value which you have just now calculated by its molecular weight, you will get the solubility in gram per liter, and so you can find out the molar solubility in mole per liter as well as in gram per liter. I hope you understood the concept of solubility and solubility product, common ion effect. Happy learning. See you in the next video.